there's a squirrel, and he's running on a clothesline and shown the graph below. Here's his velocity. It is important to know what graph we're looking at, and we are looking at the graph of, well, velocity. So again, looking at all the things that we know, this represents moving forward, this area represents moving backwards, this area represents moving forward, as if this clothesline, long straight line, was a number line. It's that sort of thing. So total distance that the squirrel traveled. Well, let's do it. Total distance that a squirrel travels is going to be, well, the distance that he travels, because he's a squirrel. No, it's not. From 0 to 15. I should have put the interval in there. But we're going to go the interval from 0 to 15 to the absolute value of this guy's velocity, but then we kind of run into a problem because we're used to dealing with an equation or a table of values, but in this case we have a graph. So what we're going to do is break it up into separate pieces, and we're going to say, well, we're going to find the area from 0 to 5 of our velocity. I'm representing it in a way that may not be represented normally, but I just want to demonstrate what's happening. And then we have the area from 5 to 13 of our velocity. But the fact is that's negative. This technically is a negative value, so if we subtract that negative, we'll have our positive. And then plus the interval from 13 to 15 of our velocity. There we go. So we're going to figure out what all of these are and deal with them appropriately. First of all, we have the first triangle. This first triangle is 1/2 base times 5. And I don't know, I'm skipping to the triangles apparently. I'm just really into triangles right now. 1/2, 2 times 2. And then this trapezoid right here is going to be 1/2 height, which is 3. And, I lied. My height is 3, but my height is -3. So you can say minus 1/2 -3. I'm going to go ahead and go like that. It's going to work out. This negative just got canceled by the fact that this technically was a -3. And so 8 plus 4 plus 4. There we go. And I end up with 15 plus 6 times 3, so 18. Plus 2, which last time I checked, was 35. 35 what? Total distance the squirrel traveled, and it is measured in feet per second. Velocity is feet per second, so this must be feet. So at t equals 11 seconds, was the squirrel speeding up or slowing down? Oh, whoa, we're going back a little ways, aren't we? Okay, not back like backwards on the clothesline necessarily, but what is the velocity at 11? What is the derivative of velocity at 11, which you could also say is the acceleration at 11? Okay, I don't want to just say A of 11 equals whatever, because then the person who's grading my paper wouldn't know, A, what's A? I mean, they know it's velocity, and I know it's velocity, but they don't know that I know it's velocity. Anyway, velocity at 11, it sounds like a news report. Velocity at 11. With a weather report to follow. Velocity at 11 is -2. Let's put units for fun. Feet per second. And the acceleration at 11, what's the slope at 11? Well, it's 1 foot per second per second. Now, why did I do that? Because of an older lesson that says speeding up and slowing down has everything to do with the signs of velocity and acceleration. And so because velocity is negative, acceleration is positive, here's the bigger reason. Because they have different signs, the squirrel Miss Bushytail is slowing down at t equals 11. I'm assuming they asked to justify it because I said so. Because velocity at 11 and acceleration at 11, which I just defined over here, have opposite signs. Opposite signs. Okay, how far was the squirrel from its starting point at the end of 15 seconds? Okay, do you want me to reword the question? What was the squirrel's displacement? That's what it's really asking. Displacement for the time period from 0 to 15? That's the question. You don't have to write all that now that you've already written all that. But that's basically what it's asking. How far was it from its starting point? So it starts at some point, forward, backward, forward, backward. Forward, backward, forward. And then where did it end up relative to its starting point? So we grab the purple pen and we keep on going. So we've done this already, actually. We can do the integral from 0 to 15 of velocity. We did it, but we didn't do it because we had absolute value. And so we end up with these three separate pieces. We end up with the triangle. Let's just go ahead and jump straight to what we know. Positive triangle, negative trapezoid, positive triangle. 15 minus 18 plus 2. That was negative. 15 minus 18 plus 2. And that's going to give me negative 1. So let's put this in words. The squirrel was 1 foot to the left of its starting point at t equals 15 seconds. Okay, for the sake of physics, we'll let the clothesline be marked as a number line. I mean, who wouldn't, right? Assume that the squirrel's starting position on the clothesline represents the position of 3 feet. T equals 7 seconds. Was the squirrel traveling toward or away from its starting position at 0 feet? Justify your answer. Whoa, what? Okay. It might help to jump back to like middle school, early middle school, and draw a number line. And I know this seems elementary, but trust me on this. This is where the squirrel started. And I want to know, is the squirrel traveling toward this 3 or away from this 3? Now, let's notice what could happen. The squirrel could be traveling toward the 3 from this side or from this side, or it could be traveling away from the 3 on this side or this side. That 3 at t equals 7 seconds was the squirrel traveling toward or away from its starting position at 0 feet. Oops, that should say 0 seconds. I want to correct this in future versions of that. So 0 seconds. No wonder it felt so wordy. 0 seconds. So at 0 seconds, we were at 3 feet, or the squirrel. We weren't. I wasn't there on the clothesline with the squirrel. I don't think that'd work very well. It might not work for a squirrel to run on a clothesline, but whatever. So at 0 seconds, the squirrel is at 3 feet. So at t equals 7 seconds, was the squirrel traveling toward or away from its starting position? Okay, so here's what I need to know. This is a tricky question. I would like to know a couple things, and I'm going to write out my thoughts in blue. Where was the squirrel at t equals 7? T equals 7. I need to know that. That doesn't answer the question, but it's going to help me get there. So was the squirrel over here? Was the squirrel over there? Was the squirrel somewhere in between? Like, I don't know. What was the squirrel's velocity? Velocity, we'll get it right, at t equals 7. I did it again. I turned a 7 into a question mark. What was the squirrel's velocity at t equals 7? Don't know. Let's find out. And actually, I don't care what the squirrel's velocity was. I only care if the squirrel's velocity was positive or negative. I only care about the sign of the velocity. So I'm going to answer these two questions, and then you'll see why we asked them in the first place. So where was the squirrel at t equals 7? Okay, where was the squirrel? Well, the squirrel started here. I'm going to just sort of work this out. Location at t equals 7. Okay, so squirrel started at 3. Just 3. And then scampered back and forth and back again, but back and forth. And this is where the squirrel, for our purposes, sorry, there you go, just kind of stopped the process that we were doing. So that plus the integral from 0 to 7 of the velocity. Here we go. Original location, initial condition, you could say, initial position, plus displacement will tell me where the squirrel was. So we'll figure this out. We'll go ahead and do it right now. So 3 plus 0 to 7. 0 to 7 is going to give me 0 to 5, which is positive 15. We've already played that game. And then we're going to have this area right here. This area right here is a little trapezoid. It is slightly negative, so it's going to be 1/2 height, which is -3. So 1/2 height of 3. I'm already subtracting it, so we'll just go ahead and put the negative with there with that one. And base 1 is 2. Base 2 is 1. So one of them is 1, one of them is 2. So 1 plus 2. And we're going to figure out where the squirrel was. And we do have to justify our answer at the end. So we have 18. Let's see, where am I? Minus 4.5. 18 minus 4.5 is going to give me 13.5. So here's my squirrel. Miss Bushytail is right over here at 13.5. There she is, a little red squirrel with a bushy tail. And I don't even know what that is. That does not even look like a squirrel. I'm a little confused about what that is. It's like a no-armed dinosaur with a horn. But anyway, there's our squirrel. Now, I've got her facing this way. If that's even her head, I don't know. But the truth is, I don't know her velocity. And I'm going to find out what her velocity is. And it's going to be a really easy fix. So here goes. Velocity. This is a different issue altogether. Velocity at t equals 7. Handwriting's getting sloppy. Getting sloppy. The velocity at 7, actually really easy to find, -3. -3. Here's what that tells me. So little Miss Bushytail is here and is going to the left because of the negative velocity. She is running toward her initial position at 3. That was the question. So here we go. At t equals 7 seconds, was the squirrel traveling toward or away from its starting position at 0 seconds? So at 0, it was here. At 7, was it going toward or away from that? I could have worded it better. Apology for that. But homegirl is running toward it because, and here's the justification we're going to write in just a second, she is to the right of it, the beginning location, and is running to the left. She could have been to the left of it and running to the right. So here we go. Let's put it in words. Let's use red. The squirrel, not spelled in order. I'll put the Q then the S. The squirrel is running toward its initial position. Here's why. Because it, he, she, I've been calling it Miss Bushytail. So she is to the right of 3 feet at t equals 7 seconds and is traveling to the left.